Welcome to another video in the series of Matrix of Time. In this one, we'll look at the concept of humans as quantum beings. What do we know about matter? Astrophysics has shown us that less than 5% of all matter is detectable by us, and this 5% is what we use to develop our physical and biological theories on. Dark matter is undetectable matter that has to be there to generate the gravitational force necessary to create the universe as we measure it. Now, dark energy is undetectable energy needed to explain the measured expansion of the universe. So 95% of matter is undetectable to us. Please keep this in mind as we go through some of the proposed theories of matter and energy. Now, what do we know about this 5% of matter that is detectable? Well, we've learned that it has a dual personality, and it takes two forms. The first form we'll give two examples, and we'll call that form the particle form. And I use an example of Mickey. I use another example of some glassware. And these pictures show objects that have properties that are easily defined in space. That is, their position and location and size are readily defined. Now, the second form is the wave or distributed form. And as we can see right here, Mickey turns into a blob and the glassware turns into a hologram. And these two forms have properties that are not well defined in space. There's no clear position or location or size. Yet both of these, particle form 1 and wave form 2, represent exactly the same thing, and through mathematics you can go from one to the other and back again. And this is the fundamental of quantum mechanics, is that atomic particles have this dual nature. So quantum theory is based on this dual nature of all atomic particles. So all matter in the universe has this property called particles. It has a defined location in space, and this property is also known as local. It can be defined in a place in space. But it also has another property that we call the wave property. This has no defined location in space. This property is also known as nonlocal, and it cannot be defined as a place in space. So the dual nature of the atomic world is that it's local, easily defined in space, and non-local, not easily well defined in space. So local is particle and non-local is wave. How far does this non-local distributed property extend? The physicist David Bohm theorized that every particle must be in contact with every other particle in order for each particle to know how to react in each situation. This means that each particle's distributed wave property is everywhere in space. Another physicist, John Bell, used David Bohm's model to develop the theory of entanglement, which explains the spooky action at a distance, as Einstein called it. In John Bell's entanglement experiment, two or more particles remain linked independent of the amount of space between them. They can be at opposite ends of the universe. If one changes a property, the other must immediately change to obey the laws of nature, since that property is not dependent on time. To date, entanglement has been proven many times to be a property of matter. As much as it's hard to understand this, it means that the non-local part of matter is everywhere in space. Now, how does space and time relate to the dual nature of matter? The shape of galaxies, stars, and atoms are easily defined in space, so space is part of the local property of our matter. But time is everywhere in the universe, from the galaxies to inside the particles. There is no place in space where time is not. This is not clock time, which is a unit of measurement, but the more fundamental time, the energy of change. So we can say that time is part of the non-local property of our matter. So let's summarize the quantum properties related to space and time. All matter in the universe has the property of being easily defined in a location in space. So space is associated with the local quantum property of matter. Now, all matter in the universe also has this property called a wave property. It has no defined location in space. And now I have defined time as being associated with the non-local quantum property of matter. So how do humans fit into this quantum view, this dual property of nature? Well, it's pretty easy that our physical body fits into the particle form, which has the local property because it's easily defined in space. Its position or location and its size can be easily defined, and can be defined precisely. And our consciousness fits into the second form, the wave or distributed form, which is called non-local property, because it's not well defined in space, has no clear positional location or size. So based on this correlation, I hypothesize that humans are quantum beings. So holograms are an easy way to visualize this distributed information. So you see below the hologram that we've been looking at before, and no matter where you illuminate a small portion of the hologram, the image is the same. So we see that with the top left corner and also with the bottom right corner. So this information of the glassware is distributed all over the hologram. So now let's use the same hologram idea to look at the distributed information to visualize consciousness. Your consciousness, represented by the distributed field throughout your body, contains you in all parts of the physical, similar to the way your DNA, with all your biochemical information, is distributed throughout your physical. So you can see here, the first part, you can find the you in your head, you can find the you in your heart, you can find the you in your fingers, and you can find the you in your knee. So you are distributed throughout this field of consciousness. So one of the properties of quantum theory is that it can predict the behavior of a group of particles, but it cannot predict the behavior of individual atomic particles. Sociology and psychology can predict behaviors of groups of people. Sociology, for example, does a very good job of describing the attributes of a large group of people, like a culture, for example, but it cannot predict the exact behavior of a particular individual within that group or culture. Psychology predicts the behavior of a happy or sad group of people well, but it cannot exactly predict how one single happy or sad individual will behave within that group. Defining the exact location and physical attributes of an individual in space does not seem to have this problem. So we have the quantum property of self-interaction. In the atomic world, the atomic particle changes between its particle form and its distributed form depending on how the experiment is set up. In particular, if the atomic particle is being observed or more accurately measured. The I, the consciousness of who we are, interacts and views the actions, thoughts, and emotions that motivate us. This I expresses itself differently in different environments and based on who is watching. So let's explore that a little bit more. So now that we've put the hypothesis forward that humans as quantum beings, we have to tackle the next topic, quantum observer. That is the effect of watching or measuring particles in the atomic world. So in the top left-hand corner, we'll see that there's a person and have the eyeballs above the person designating that they're observing, and the ruler on the bottom is that measuring. These two operations are considered to be the same thing. And if you try to measure an atomic particle's location, it will automatically manifest in the particle form. If you don't do any measurement, it will automatically behave as a wave shown in the bottom left. So this can be a bit confusing, so I'm going to try a number of examples to try and explain this effect. So let's try in the first green box on the right, and in here I have the eyes closed and the rulers crossed out, meaning that we're not trying to make any measurements and we're not watching anything. And in the second green box to the right, you have eyes which are open and a ruler. So in this case, this would be the observation state because we're either looking at it or trying to make a measurement. Let's start with a person playing tennis by themselves. Nobody's watching them. The next green box on the right-hand side, you have a tennis player who is being watched by one individual. Just having that one individual watch them will change the way that they behave. They will be conscious that somebody is watching them, and in subtle ways they'll start changing the way that they're playing. Now let's consider that they're in a stadium and there's a group of people that are cheering them on, shown by the group of people in red. That will change their behavior. And the same way that if there's a group of people in the stadium shown in the blue who are possibly booing them, that will also change their behavior. So we as humans are not independent, those observing us. The other example is of, let's say, a person taking a test. They're doing it by themselves. There's no time restrictions and there's nobody watching them, and they can take as long as they want. In the example on the right-hand side, you have, say, a professor watching them, and there's a stopwatch on every question that they're doing, and they get notified how much time and when they've exceeded the time. That will dramatically affect the behavior of the person. Now, in some cases, it will cause the person to score more poorly, and in other cases, it might motivate the person, and they actually will do better under the pressure. But in either case, it's going to change the status of having them either observed or some measurement is changing the way they behave. And that's what I'm trying to express in this slide. So now let's talk about the famous dual slit experiment. The initial experiment was done with 2 slits to prove the effect, but it does not have to be limited to 2 slits. I decided to use 3 slits to highlight that any number of slits can be used. So we start with a situation where a particle has 3 possible paths to go through. There's 3 slits, a green, an orange, and a red one. And in this experiment, we're not going to observe which slit the particle went through. So on the left, the particle starts in its distributed waveform, and on the right, the particle is captured by the detector in its waveform mode. Because we did not have a detector at each slit, we could not tell which slit the particle went through. On the basis of physics, it took all paths simultaneously. Now let's look at the situation where we actually try to observe which slit the particle goes through. You can see that the difference with this one is that there are 3 cameras, one in each one of the slits, and these cameras are hooked up to a detection system. And it's set up so that when this particle moves and gets to a point right before it goes through the slits, the detection system is triggered and the camera will capture which path it took. Now, right before the particle went through the slits, it is in a distributed form, but the moment that the camera is triggered, which is the act of observation, it immediately, as they say in physics, collapses into the particle form, and the camera detection system recognizes that the particle went through the red slit. And then the detector at the end registers the particle in its particle form. So another experiment on the observer effect that scientists did is called recreating the past billions of years ago. And so basically there was a quasar that exploded, and it's 10 billion light years away. And the light from this quasar traveled through the universe, and it bypassed some galaxy. And we know that the gravitational fields of the galaxy are strong enough that it'll bend the light like a lens. And so astronomers here on Earth took that light and then focused it. And so the first detection is right at the point where photons that took the blue path and photons that took the red path created an interference pattern. And at this point, the scientists could not tell whether the photons took the blue path or took the red path. And so therefore, it shows a detection pattern synchronous with a distributed form, which is an interference pattern. Now, if they move the detector past this point, now the scientists can detect whether the photons took the blue path or the red path. And immediately, the detection format changes to one of a particle. So they can go back and forth, even though this light has been traveling at 670 million miles per hour for 87.7 trillion hours. So a long way away. And so this dual nature of the atomic world is there always, no matter what distance, no matter what time. And if the observer effect is changed and you can detect which path the photons took, they'll immediately change the way that they manifest. So the quantum observer experiment begs the question, who is watching whom? So in the top left, we see that the observer, us, is either by watching or by measuring the atomic particle, changes its behavior either as in particle form or in wave form. Or is it on the other side, on the right-hand side, where the atomic world is watching us, and how we set up the experiment, it is determining whether it's being watched or not being watched. Or is it the last one on the bottom, where we are watching or measuring the atomic world, and the atomic world is watching and measuring us, and there's an interaction between the two that changes the behavior of the atomic particles. For me, based on the hypothesis that I have, the answer would be the bottom one, where we are observing or measuring the atomic world, and the atomic world is watching and measuring our actions. So, why did I choose the bottom option? In the slide there's a hint. It's called Entangled in Time. In the top we've got the human observer with their eyes and their equipment to measure, and the human observer has a distributed waveform in the holographic universe, and the atomic particle also has a waveform in the holographic universe, and these two are linked together. So there's a part of us distributed throughout the whole universe, and there's a part of each atomic particle that is distributed through the whole universe, and they are connected together in time. So I want to just talk about how the non-local part of the atomic particle and of our consciousness is entangled, that is always connected. So it is as if we are both watching each other and reacting instantly. But this whole concept of entanglement is really important. So time and the dual nature of matter. If we look at our universe, it has 3 variables of space and 1 variable of time. And I've denoted a cube as space, and below it I show some galaxies swirling around our universe, and then the distributed green pattern in the back is the 1 variable of time. Now let's go back to space. Space has length, area, and volume, and the location in time is easy to define. It holds the local or particle form with length, width, and height. Now the single variable of time, the energy of change, is everywhere in the universe. It connects everything together. It holds the non-local or waveform of matter in terms of frequency, energy, and mass. Takeaway messages. Our knowledge of the universe is based only on 5% of the total amount of matter and energy. This 5% has a dual personality. It has a particle and a waveform. Holograms are an easy way to visualize this distributed form. Quantum theory is a model that uses this dual form of matter. 2 forms, physical and distributed, are used to show how these two correlate to our physical form and to our distributed consciousness. Based on this analysis, I make the hypothesis that we are quantum beings. Quantum theory can accurately predict the behavior of a group of particles, but not any single individual particle. Sociology and psychology have these same properties. The eye of our consciousness changes based on whether being observed or not. The particles in the atomic world change their nature depending on whether they are being observed or not. A number of examples and experiments were discussed to describe the quantum observer effect, the act of observing the atomic world. Time, the energy of change, is associated with the distributed or waveform of matter. In the next video, we'll explore quantum beings in time. If you want to hear more of these Matrix of Time videos, please subscribe below to be notified of new presentations. You can also go to my website, www.multidimensionaltime.com, and there you'll see that there's a book available. There's also some technical white papers, and all the links to my videos that are available on my YouTube channel can be found on my website. Okay, thank you very much.